Okay, welcome to my new channel. I want to show how to use SDSM software for determining the future precipitation, temperature, or any other values. Now, first of all, this is the home page, and then settings. First of all, your length it will be calendar 360 because the leap year month will be allowed for prediction. Now, my data were 2002 initial birth date 2000 January to 2016. That means around total 17 years data available in my platform. Okay, now this is the miscellaneous and event threshold. It will be 0 for determination of minimum and maximum temperature. Okay, and finally default file directory, it will be minimum and it will be Sayadpur station for me, and I click on Sayadpur station. And next, the advanced setting for the precipitation, it will be fourth root, but I want to predict the temperature, minimum temperature, so I use here none. And optimization algorithm, it will be dual simplex. I only use this dual simplex method, so it will be saved. It's okay. If you have not, first of all, you click on dual simplex. Okay. This is save, and this is back. This quality control. The next step is used quality control. Check your help. First of all, you use the dat file which you already created. The how do you create the dat file? You can see my next tutorial, which is given below. Okay, first of all, it check 6210 values processed in Saidpur for minimum temperature. This is dat file. Okay, the minimum value, that means the minimum temperature for one day is 3 degrees Celsius, the maximum 31, and minimum value, mean value, the number of values, the total number of days 6210. I use that. And the missing value 999 minus 999. Okay, transfer value I needn't. The transmit value I go to go the screen variable. Next, the screen variable. First of all, select the file and the sideboard main temperature. Okay, now it will be the fit start date. Okay, then the end date. It's okay, no problem. Now, first of all, we need the predictor variables. Determination of public predictor variables. For SPSM, GCM, NCER, NCEP, NCR predictor. There are 26 predictors, so we can only use two predictor among 26 predictors. Okay, so first of all, for the better weather, we use the correlation among first 11 predictors. Yeah, we get the partial value R and P value. There is the partial value, there is the P value. Okay, for us, we need we need must be sure that the P value should be minimum and the partial value must be maximum. Okay, the p-value minimum is seen that the most of value were 0. Okay, here is the minimum value where 5000, that means 3000, that means another 4, that means total 7 p-value are minimum among 11 predictors, and I use only 2 predictors this among the 7 predictors. Okay, the one criteria is the p value will be the minimum, and next the partial r value will be the maximum. So first of all, you can see this p value is minimum, the partial value r is the maximum, where the p value is minimum but the partial value is minimum, so it's not needed. So another minimum, around minimum, so we can check minimum, not needed. We can use 56, 148, 431. That means we can use first and uh, ninth. So we can write it for our text or for any document, one visual value, and next a pp 5000 real value. Okay, next, now we compare the next value and correlated the next correlated the 11 parameter can be used. Mistake. First 3 parameter were unchecked, so no problem. We can use the second time. The correlation. Yeah, the correlation. Okay, the correlation. The p value is minimum. Okay, but it's not maximum. It's minimum. It's not maximum. Minimum. It's the maximum value of p. Minimum, not maximum. Minimum is the value of maximum value of p. That means we can consider the p value minimum and the r value maximum 272. That means VGL 8 VGL, and another is CPGL. Yeah, sorry, yeah, it's the 0 and 85. It will be 85 GL, the maximum value. Where 270, 270. Okay, we get already 2 predictor, and then the next, the rest of all, we use the rest of all predictor and correlate. Now we get the last 2, and this is the best way that you read it in a pad or any documents. Otherwise you can stolen it or lost it. I want not lost it. This is the value I correlate along 6 predictor, which I already got by correlation. And yeah, first of all PGL one PGL. Okay. Now correlation, and I want to get only one, sorry, only two predictor. Yeah, the p-value maximum. There is no problem. This p-value is maximum 5 among 6 values. So we use the maximum value, minimum value is minimum value and maximum value. Last two, last two are the maximum value of R and minimum value of P. Okay, this is correlated. Okay, no problem. Now, next step to go calibrate the model. Next, so I put temperature and I write it Sayat 4. This is my station name. You can use any name, but you must be create par file. Okay, no problem. Okay, the predictor. Okay, and finally the predictor. Okay, model type it will be monthly, seasonal, annual. It will be created three types, and auto regression will be included, and chart test will be also calculated. Okay, no problem. I want to calibrate. I want to calibrate. Yes, I want to calibrate it. Okay, already calibrated. The result will be shown here. Okay, good. There is no problem. Last scenario generator. This is so the par file is imported, and observed value will play the historical. Here is the historical. Here is the historical. Okay, no problem. We can view our my data. Select our output. You can make this name. I write it Tmin temperature. Okay, no problem. Observation. OBSERPED. Observe. Okay, no problem. It will be automatically created output part. Okay. Now it will be must be. Notice that it's first of all, before generate, first of all, need to setting, and it will be 365 because the SDSM software manual shows that the calibrate model cannot read a scenario generator in leap year. Okay, so we use only uh, without leap year. So first of all, we go settings, and here the it will be the 365. Now generate. It's no problem. Okay, generate. Next. Mm, time consuming on is created. Good. Our work is already done. Now we can summary statistics. So input file it be observed, and next of all it will be very important analysis period. The analysis period which is used for observation, it will be must be the initial value and the final value which is used for the scenario. Yeah, yeah. The data is collected for me in 2000 to 2016, and here is my data analysis period. It will be view. You can see the predictor 2 season code 12 ELM 365. Okay, scenario started and 2000 and number of days 16426 45 and sample size 20. Okay, now we can analyze it. Before analysis, no problem. Okay, now I can analyze reading data and calculating process, and this is our observation data. Okay, no problem. We can observe our data and we can also save it as a PDF file. You can, or you can, as you wish. No problem. You can or you cannot. Now, I want to show how to predict. First of all, scenario generator. And go to settings. This 365 is okay. And it will be, the last period will be 20 and the first will be the next year of observation period. That means 217. Okay, everything is okay. That means the prediction will be started at 217 to 221. Okay, it will be saved. Okay, no problem. And back to, go to the par file and here we use the RCP 2.6. Okay, no problem. And we name it 2.6. Okay, and now we can generate. Yes, generate. Scenario generator is already creating. And please wait. You can want to stop our work because is a okay, scenario generator is created already. Okay, now we can compare our result and scenario generator 4.5. Okay, and generate. Yes, we want to generate our RCP 4.5 values to compare our result with three scenarios. Um, yes, scenario generator is created, and last of all, 8 RCP 8.5. It will be 8.5 and okay. Yes. 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 Wait. It will be created in time. Wait. Yes. Right. Now we go in summary statistics. Go. Now 2.6 and this is time for prediction. Yes. This is a time for prediction. Okay. I want to, yeah, I want to show my data were 216 minus 220. That means 17 years. This is not a big data. Okay, so we can divide it into, yes, 8.5. That means if we want to determine 235 minus 8, that means the initial value will be, yeah, the initial value will be 257. Yes, and the final value will be, and the final value will be 235 plus 8. Sorry, 8. Yes, 233. 233. Yes, we got. We will be get. We will be got. Yes, we will get 6. And scenario will be 35. Yes, it will be must be 35. Yes, and now this is time for analysis. Yes, go, and it will be calculating. And yes, we get it. Yes, we get it. And now we use it 2.6 and create a name 235. Okay, PDF file. I needed, so I save it, and I also use 4.5 scenarios and also the same procedure. Okay, there is no problem. You can use only one, two, or three RCP scenarios. I use it because the three scenarios make sure me compare my result accuracy. Okay, this is the same process. Data is not needed. Okay, yes, I want to get the next one. Okay, this is finally 4.5 and 335. Yes, get it. Okay, back. And now the next 8.5, 8.5, 8.5, yes, 8.5 are scenarios. Yes, view and analysis. And the same process for 235, 240, 250. I want to determine the 250, and so 8.5. Yes, yes, there, there, to 6, and analysis time period will be, it will be changed, and it will be 42, and it will be 58. Yes, and it will be 50. Yes, you get it. Yes, yes, yes. Analysis, skipping, first of all skipping, then reading, and finally calculating, and last of all showing the result. Yes, thank you. Thank you, SDSM. Thank you very much. You are really hero who created the SDSM, the creator of SDSM. Yes. Now RCP 4.5 scenarios. Okay. Now 50. Yes. 50. Yes. Yes. The reading, calculating, and showing. Yes, showing. Finally, it will be 4.5. Yes. Good. Very good. Yes. 8.5. Ah, 8.5. And it will be 8.5. Yes. 250. Yes. View details. And skipping first of all, then reading, then calculating, after that showing. Yes, showing. It's hard. Yes, sure. Okay, this is good. Big. Now we use 2.5 scenarios, and analysis period be changed. And analysis period will be 85, and I want to predict 85. Okay, to 85 years. So it will be calculated in plus 8, that means 293, 2093, and it will be, the initial value will be 277. Okay, 2077, 77. Okay, no problem. Yes, yes, 2.7 to 7, 25. It will be 85. Yes. Ew. Analysis. Analyze. Take more time because the time period is more. Okay. Okay. This is the time. Okay. Yes. Now Yes, 2.6, 2.6, 85. Yes, 10, 10. And for SB 4.5 values, it will be 85. Okay, it's a simple method. Okay, yes, 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 yes. We get that meantime. Yes, get now will be 85. Okay, 85. Yes, 85. Yes, 85. The next and last. Next and the last. 85. Yes. Else? Else. Yes. Get it? Finally. Let me show it. Compare our result. This is the observed value. This is the observed value. This is the observed value for the soil station. ঠিক আছে? Okay, no problem. Yes, but copy and now we want to save in soil pool minimum temperature. Yes, soil pool minimum temperature. Get a graph paper. Yes. SIDPUR, yes. Go. Now, this is we created our scenario name, 4.5, RCP name, 5, and first of all, use the put result. Yeah, result. Our process is the same. The main value, and bar chart will be copy, and then next will be put it in Excel file. It will be great, good, and okay, it will be good. It will be good. I think. 4.5. I observe. 4.5. Bar chart copy. Yes. 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 Next. Next. 50. 5. Bottom. Copy. And then next. Yes. 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 And the same procedure for the CP.5. Okay. 8.5. Yes. Bar chart. Copy. Now paste. Yes. Now the next and the last. Yeah. Copy and yes. 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 Okay. It's the completed data. Back.